In this unit, we've been talking a lot about how computers use logic to make decisions. Today, what we're going to be looking at is these number factories, which a lot of times in mathematics or in computer science, they're called functions. And essentially, what we're looking at is how a computer would take input, process that input, and then produce output. So for here, in this problem, I have an example of a number factory. And what I'm going to do is I'm going to run through several inputs here, and we're going to see how the computer is going to take those inputs, analyze them, and produce an output. So let's say the first number that I take in is 6. All right. So if I take in the number 6, I'm looking at these requirements here in my number factory. So I look at the number 6. If the input is even and greater than 8, well, the input is even, but it's not greater than 8. So it does not pass this one, so I have to go to the otherwise. So my output here would be add 3 to the input, so my output from 6 would be 9. All right, so let's take a look at another example of an input here. If I put in the number 9, if the input is even and greater than 8, well, 9 is greater than 8, but it's not even. So again, I would go to the otherwise, and the output here would be 12. So again, for these AND statements, I have to satisfy both conditions in order for it to be true. Neither case that we've tested so far has done that. So let's try a number that would satisfy both of those. Let's try the number 10. So if I put 10 in the input, it is even and greater than 8, so I'm going to multiply it by 2. Therefore, the output is 20. So that's how a number factory like this works. It takes an input and pairs that input with an output. A lot of times we might write it out something like this. 10 goes to 20. And in your math classes, oftentimes you see this as an x value and a y value. If you put an x into equation, you get the result of a y value, input and output. So let's try another number factory here. Let's try number factory 2. This one says if the input is less than 5 or odd, multiply the input by 3. Otherwise, subtract 6 from the input. So let's test a number like 4. All right, the number 4 is less than 5 or odd. Now remember, for an OR statement, only one of them needs to be true, so this satisfies this first part. It's not odd, but it is less than 5, so we're going to multiply the input by 3. Therefore, 4 is going to pair with 12. If we try another one, let's try the number 9. The number 9 as an input, it is not less than 5, but it is odd. So therefore, we still have satisfied this condition, so we're going to multiply the input by 3. Therefore, 9 times 3 is 27. Let's try one more on number factory 2 before we do something else here. So if I try the number 10, the input 10 is not less than 5, nor is it odd. Therefore, we don't follow these instructions. Instead, we go to these instructions, the otherwise. Otherwise, subtract 6 from the input. Well, that would make our output 4. So in those cases, 4 paired with 12, 9 paired with 27, and 10 have an output of 4. Now, I'm guessing these are relatively simple, but now what we can do is we can put 2 of these together. So for instance, if I have number factory 1, oops, I'm trying to just resize it here, so just bear with me for a moment. Okay. If I have number factory 1 and number factory 2, and I take an input from number factory 1, and I say, well, I'm going to put in the input of 4 into number factory 1, then what I'm going to do is I'm going to directly connect the output of number factory 1 to the input of number factory 2. So I don't even really care what the output of number factory 1 is, other than the fact that I'm going to put it in as the input of number factory 2, and then look at my final output here after it runs through both machines. So as I look at this, 4, the input is even, but it is not greater than 8, so I'm not going to multiply by 2. Remember, both of these have to be true, so I'm going to add 3 to the input. So the output of number factory 1, what gets carried along this line right here is the number 7. Right? Because it didn't satisfy this, we had to add 3 to the input, so we have 7. 7 now becomes the direct input into number factory 2. So 7 is the number less than 5 or odd? Well, yes, 7 is odd. Therefore, we're going to multiply the input by 3. So for this particular example, 4 went to 7, which then went to 21. So when we put these two number factories together, we went from 4 to 21. And again, this 7 is only a temporary result, and really all we're concerned about is that when we put number factory 1 together with number factory 2, 4 went to 21. So let's try another input. Let's try the input of 10. So if I put in the input of 10, well, 10 is even and greater than 8, so I'm going to multiply that input by 2. And again, we're going to connect the output of number factory 1 directly to the input of number factory 2. So we get an output here of 20 for the time being, and that's going to come in and be our input into number factory 2. So this one says if the input is less than 5 or odd, multiply the input by 3. Well, 20 is neither of those. So instead, we're going to subtract 6 from the input, which would result in the number 14. So what we have here is 10 went to 20, which then went to 14. Now, you can probably imagine that we could string together as many number factories as we wanted. So I could have a third number factory where the output from factory 2 would go to the input of factory 3, and we could continue to do this for as many number factories as we wanted. Now, oftentimes, what we see are not going to be these number factories. In other words, there's not going to be a picture that is associated with them, but rather they're just going to appear as words. So for instance, we see if a number is greater than or equal to 6, add 7. If the result is divisible by 3, subtract 10. And if that result is even or greater than 13, add 2, otherwise multiply by 3. So let's take a number like 8 as our initial input, and let's trace how it goes through this. So if a number is greater than or equal to 6, add 7. Well, that means with an input of 8, my temporary output is going to be 15 because it is greater than or equal to 6. So now I take that 15 and I come here with if the result is divisible by 3. Well, is 15 divisible by 3? Well, yes it is, so we're going to subtract 10. Now the place where a lot of people get confused is they think that when they come to this part, they should go back to the original input. But that's not the case. We're connecting these together just like we did with the number factories. So this output becomes the input of the next line. So if the result is divisible by 3, subtract 10. Well, 15 is divisible by 3, so we're going to subtract 10, and we get the temporary output of 5. And now, if that result is even or greater than 13, add 2. Otherwise, multiply by 3. So this 5 is not even, nor is it greater than 13, so we're going to multiply it by 3. And we get a final result of 15. All right, let's try one more input. And let's try an input of 6. All right, if I put in the number 6, it says if the number is greater than or equal to 6, add 7. Well, if this just said greater than, this would not be true, but it says greater than or equal to 6. So this is true, so we're going to add 7, which we get 13 as our temporary output. We then take that 13, put it in for this input, and it says if the result is divisible by 3, subtract 10. Well, 13 is not divisible by 3 evenly, so what are we going to do? Well, it doesn't give us instructions if that's not the case, so we don't do anything. So our temporary output in this case doesn't change from the input. It just passes directly through this without any change. So now 13 is the output of this, so 13 comes here. So 13 is the input. If the result is even or greater than 13, add 2. Well, 13 is not greater than 13, it is equal to 13. So while we might be tempted to add 2 here, that's not the case. We're going to follow this instruction because 13 is not greater than 13. So we're going to multiply the input by 3, and we get a result of 39.